hour. And now, what is all of this in service of, Tyler? Why am I using the wind that's blowing in West Town 1 right now? What is it that I'm trying to predict?
You're trying to predict the current wind value in Bemidji using linear regression with a bunch of different points.
Okay, yeah. So it's fair for me to use now values from other locations, because what I'm trying to predict is the now value for Bemidji, which is the blue stuff at the end here. And so last time, is this an improvement over last time? How is this different from last time?
There's a lot more data spatially, so.
Yeah, I'm bringing spatial stuff into it.
I assume it has a wider data range to pick from. It has multiple variables to choose from when you're trying to predict something. So.
And probably out of this dozen or so variables, only 3 or 4 of them are going to be any good. Do you have any idea what might be good just by looking at these, from what you know of weather and space and time?
If I knew the wind cell in Bemidji, I might be able to make a guess, but I don't know. I don't know how big
So
it is
you're,
in Bemidji.
well, you're trying to predict the wind in
I'm
Bemidji.
trying to predict it. If I had to,
So you wouldn't need to make a guess if you knew the wind in Bemidji.
it's either going to be, I'm guessing it's either going to be, like either the west town was 3 time units ago or the east town 3 time units ago. I'm not sure which way wind comes actually, but that's my guess.
I think I actually asked a chatbot which direction the wind blows seasonally in Bemidji, and it actually had some sort of answer for me. I think like in the autumn, the wind tends to come from the west, and that's certainly what I seem to remember from experience is winter and autumn, there's a lot of western wind. Of course, I think the wind came from the west for the June storm this summer too, so I basically think that the wind mainly comes from the west in Bemidji. I may be wrong about that, but that's just my general feeling, which makes me think that eastern town values, I don't think they're going to be very helpful. What I do like about mixing the U's and the V's together in this schema here is that it allows me I'm going to use all of this black stuff to predict this guy, and then all of this black stuff to predict this guy. I mean, this table of data that you're getting returned to you, you're meant to use for 2 separate models, a U prediction model and a V prediction model, because Excel is going to ask you to choose one of those columns to key the coefficients to. So this is just a preparation to build 2 separate models, U and V. I don't believe I asked you to do wind magnitude predictions this time. I don't think that they were super successful last time, but that's why I had you do them last time, is so that we could get an idea of, hey, can I use predicted U's and V's to come up with a predicted magnitude, and would that be anywhere close to reality? And I don't know if, I mean, my hope was by combining the 2 predictions in the predicted U and the V, whatever bias and wrongness was in the U prediction, maybe it would cancel out some of the wrongness in the V prediction by putting them together. And so, I mean, if your RMSE for U and V separately were like 3 and 5, and the RMSE for magnitude prediction by using those predicted U's and V's ended up being something like 3 or 2, I would think, wow, some cancellation actually happened here. I feel like in reality, if you have any error in the stuff that you're using and putting together to build your prediction, errors never cancel out. They're always additive. And so I feel like using predicted values to come up with predicted magnitudes was probably a terrible idea in the first place. But since we had a predictive U and predictive V model, I thought, heck, why not use them? Why not test this out? So I don't know, I haven't looked at your assignments yet for homework 5. I don't know if that was your experience too. Do you remember, Mr. Kapitsky, what was your RMSE for magnitudes versus everything else? Was it bigger than everything else?
I haven't got to it yet.
What? But homework 6 is due today, Mr. Kapitsky. Homework 5 was the huge assignment before the even huger assignment of homework 6. I mean, my whole point for dumping this on you like last week was so that you would have it done by this week, so you wouldn't have it hanging over you on Thanksgiving, and you would, after Thanksgiving, be able to focus on your airfares assignment. That assignment I'm dumping on you like tonight, or maybe tomorrow or something. So you're going to have 3 assignments queued up in databases alone. What else do you get from this homework description? Have you started on this? Okay. Have you started on 5?
I did it.
Okay. So 5 was supposed to give you some ideas. What were your conclusions from 5? 5 was just using the same data, U, over time, to predict the next U over time. And I feel like most people's conclusion was that using a time series of data kind of produces a lagged result. Whenever you show the prediction versus the actual data, it seems like the prediction comes a time unit and a half after the actual data moved up. Then you see the prediction move up, which seems disappointing. And I feel like even though the predictions were smoother for the 10-point model, and so that sort of helped keep the line pretty close to the actual time series of data, the lag actually increased maybe up to 5 units. I feel like it's something like half. The lag is half of whatever the size of the time series was, mainly because we're generating the slope of that time series of previous data, and that slope is really most accurate in the middle of those 10 values. And so you're using a slope effectively from 5 hours ago, and so I feel that if your prediction is based on that slope, then having things happen 5 hours later than normal kind of makes sense. It's never been exactly half. I think it's for 10. For the 10-point model, I think the lag is feels more like 4 than 10. I'm pretty surprised that using more data, that the 10-point model actually gets a better RMSE than the 3 or the 5-point model, even though there seems to be more lag to it. But I think the smoothness is what is helping us out. Then again, I feel like there's going to be some limit as to how much previous data that I can add. I mean, more previous data is just going to make the lag worse, and at some point, the 2 lines are going to separate such that RMSE is going to plunge, or rocket upwards, I guess. So this is my attempt to try and correct that. What do you think about this, Dane? You think it's going to work? I mean, I wouldn't ask you guys to go to all this effort if it was going to be completely useless, right? Unless I don't know myself and I'm just throwing more tests at the wall. Oh man, you're all thinking this dude doesn't know what he's doing. He's just asking us to test extra stuff.
Well, from what I did, I'm not all the way through the assignment, but I got part of it done, and it seemed...
5 or 6?
6.
6?
Yeah.
Yeah.
And just the first training data set compared to the U and the V, from what I saw, looked pretty all right. It wasn't...
Better than 3-point model or 5-point model or 10-point model?
I want to say it was better because it had a smaller... the 10-point model smooths out.
Yeah.
And the 3-point model and the 5-point model had those big lag dips. But from what I saw on this one, this had a more constant Like it wasn't perfect,
Yeah,
but it had a more constant.
less of a lag?
Yeah,
Is that what
like
you're trying to describe?
it had a yeah, it had a more. It was kind of like the 10-point model where it had like the medium, but the medium and the 10-point was very flat. This had a better. It's like there's still a lag, but it had an up and down that mimicked wind patterns
Yeah,
better.
okay.
Yeah.
So yeah, I think that is the influence of using spatial data over just purely temporal data, is that it should attack that lag problem that just makes our graphs look like we don't want to show them to anybody, because the first thing they're going to say is, hey, that's a lagged prediction there. You're predicting stuff way after it's actually happened. And I feel like people are going to mock me for my models that I've spent all Thanksgiving putting together, Mr. Kapiski. So hopefully this helps a little bit for that. And also the real reason why I'm inflicting this upon you is to give you ideas for how to generate predictions for your airfare data, which we collected last week. And so I will be including that database with the assignment that I try to put out tonight, to give you as much time to work on it as possible, so that if you're not ruining your Thanksgiving with homeworks 5 and 6, you'll be ruining it with a final project data instead. What's all of this about generating a training data set, though? I think the idea so I asked you to generate your coefficients on the data from July 1st through 3rd, and I probably asked you for the RMSE, although I almost don't care about the RMSE. The RMSE that I care about is the RMSE for July 4th through 6th or something. What I call the testing data set, because I feel like that's closer to real life. If we here in Bemidji are trying to build a model just in case the wind picks up and knocks down our wind station and we want to have some sort of predictive model, we have to get that set up ahead of time. And so the model that I'm going to use tomorrow, I'm basically using I'm training on the data from the last 2 weeks here, and then I'm going to throw all that stuff together and get a hopefully good RMSE, and then I'll say, okay, this is our predictive model for the next week. And so whenever there's data dropouts over the next week, I assume our station is going to work most of the time, but sometimes there's a dropout for 1 time unit or maybe 3 time units until I go up and scrape the twigs out of the sensor opening or whatever. And then and so whenever we can just set up our model to automatically provide a predicted value whenever our machinery doesn't give us an actual sensor value. And so in that way, we're preparing ahead of time to have a model ready to provide us with emergency, I'm not going to call it data, but emergency approximations of the reading when our machinery fails. But also, using the RMSE from the testing set is kind of like giving us a preview as to how accurate our emergency approximation will be if we do have to use our model. The model is always going to have a better RMSE on the data that it's seen, and that's on the data that it was built with, but generally the model will always be used on data that it wasn't built on, right? It's data from the future that we haven't seen yet when we're building the model. And so that's why this is a common process for model building. Is we take as much data as we can, collect as much data as we can to build our model with, and then we chop it in half, and then we use half of it to build the model, and then we use the built model on the other half that it hasn't seen, and we trust that RMSE better than the prior RMSE. But I probably ask you to to put both in a table, just so you can see that, oh man, the training RMSE is always way higher than the testing RMSE. And also to let you see that, give you a sense that really it doesn't drop off super terribly from training to testing. And it's not always split up time-wise like this. I could just say use half of the data from July 1st through July 5th or 6th or whatever the last date is, and then test that on the other half of data, test your model on the other half of data that wasn't used to test it on. But here I just split it temporally to make more real-world sense. Although when you're building models on the job, you may just split your data randomly, one group into another, and use half of it to train the model, the other half to test it, and therefore get some sort of an idea of how predictive the data that you're using is, how good it will be in a real-world situation when it has to work on data that was not at all used to generate its coefficients. And you can suspect that a model that's split temporally like this into training and testing, if it was only trained on data from the prior 2 weeks, over the course of the next week, if we were just to use the model the model only for generating our approximations, we would probably find that our approximations are getting worse and worse over the course of the week because we're getting further and further from whatever the weather situation was that we trained the model on. And so that's why some people would rather do a random split of data into training and testing, just so both data sets are more or less the same. But again, I think that testing method is a little less realistic in a real-world sense than splitting temporally, if you're going to use temporal data in your model. So, what else did I want to say about this? I was feeling that it was too late to talk about this assignment since it was due today and everybody would be 90% done and not interested in talking about the assignment. But maybe this is helpful. Generating a testing. So testing set is July 4th through July 8th. Okay. And then generating coefficients with your multilinear regression tool in Excel from the training set only, and then using those coefficients to generate our approximations on the testing set. And collect RMSEs from both sets, like I said, so you can see that difference. And also, test your model against naive U and V predictor models. Again, hopefully, the spatiotemporal predictor model will do a little bit better than the 10-point temporal only predictor model. I doubt it will beat the naive models. The naive models are just too good, Matthew. They're too good. But hopefully it'll be a little closer. I think one of your 10-point models actually did beat one of the naive models last time. I think 10-point U actually had a slightly lower RMSE than naive U, which surprised me, but I do think I remember that from the previous time I did this assignment. Okay, so that's that. And I feel like, I'm only on page 3 of 5. What am I talking about on page 4, Sam?
Making graphs or something.
I'm sure there's going to be graphs involved. I'm going to ask you to print out your regressions equation for predicting. So coefficients times, column names, variables. So that's going to be a big, long, ugly thing. What is it? Was it an 18-column table, 2 of which are the 2 predictors, so you throw those out. One of which is just the date, which I don't think you're using date to predict anything. I think I have that grayed out so that you don't think that that's a predictor. You don't use it in your predictions. Okay, I don't see why the date at which the thing you're predicting occurs would have any effect, especially since we're not paying attention to the dates three time units prior or anything. So I ask you to compare training and testing. How does the spatiotemporal RMSE compare to the temporal only RMSEs that you did in the prior assignment? How do you think this will work in a real world situation? Is there anything you might do to improve this? And that brings us into D. If you are all more or less convinced, as I am, that Eastern data is not going to be as good and I don't really need an 18-column table, I could probably do just as good a job with a 9-column table or even a 6-column table, just keep the good stuff, and we're going to be able to tell what the good stuff is from the t-test values and the p-values, right, that come back in that ANOVA table that the multilinear regression gives us. Because up to this point, I wanted everybody to use the same data to make their predictions, and so I'm sort of limiting everyone to the same sort of bad data set. And D, I wanted to allow Mr. Kapitsky to put his good ideas into practice and say, let's throw out this terrible data and let's bring in some barometer pressure or something. I believe I said down at the bottom in the notes, suggestions, tips and tricks, that I had no particular tips and tricks to give you. There's nothing here that I know will work, but there is one thing, and I do believe I mentioned it in the tips and tricks at the very end of the assignment. I do believe there is one thing that might work. Sam.
Yes.
Do you think there was anything good about that homework 5 temporal only approach?
No.
There had to be something good. I mean, we did see positive results from at least something adding more data that was helping us build what? How was adding more data helping us in the 10-point model versus the 5-point model or the 3-point model? What did I do with the 10 columns of data? I was smashing them together into an M and a B, right? I think the one good thing that came out of that assignment is that M kind of shows you in which direction the wind is going on average, right? In the U direction or the V direction. I don't think B is very much good. It's just telling us where the line crosses the y-axis, and I don't know that has any physical meaning, but I know that the physical meaning of the slope is this is the general direction in which the wind is blowing. Over time, it's increasing this much per time unit, right?
If it crosses the y-axis, would that mean it's like going to changing direction actually?
I mean, crossing the y-axis
It'd be
is
x-axis.
yeah, it's the y-intercept. And so crossing the y-axis is what the wind was doing like 11 time units ago for the 10 point predictor model. And so that might have something to do with something, but again, going even further back in time, I feel is going to be less and less useful. So I don't really see how a B can help, but you know, in those 18 columns there, nine columns of which are going to prove to be fairly useless according to t-test values and p-values. I bet adding an M in there would be pretty good. I mean, you would probably have to create a whole new table of M and Bs for using some sort of SQL query rather than, I don't know, I guess you could do it in Excel and drag down and then import that SQL worksheet into a table in Access and then join that table to the 18 table model that puts all the data together on the correct lines for you. I feel like integrating M in there is going to be pretty good. I feel like it's going to be multiple steps of effort, and if you don't feel like you have enough time, if you're feeling rushed turning this in, I feel like you're not going to want to go to that effort. But if there were anything that I would try, anything that I would add into that table after reducing it from 18 or 15 potential inputs down to, I don't know, 7 potential inputs, who am I kidding, 5 good inputs, and then I would add one more input that I thought would be pretty good, maybe a sort of 6 input model of all the best stuff from the spatiotemporal model, might actually give me a better RMSE than the best RMSE that I've gotten so far in all of my temporospatials, even with the 15 predictors in there. So that's what part D is about, is I haven't given you the opportunity up to this point of implementing your own ideas, what might help out your prediction. And so go ahead and experiment. If you have any ideas of things that might help, put them in, and then do another coefficient regression, and then test that out by showing me the testing set RMSE for your own individual schema that I never even thought of. I would love it if you got a better RMSE than my 15 column RMSE after I throw out the 2 target columns and the useless date column from my original schema. So that's the overall idea of this project here. Any questions on that?
At the moment.
Well, if not, I don't really want to waste your time very much more if I'm feeling like a lot of you are about to be 3 assignments behind. So maybe I'll just let you go, hey? Or no, if I let you go right now, you'll use the remaining 20 minutes to do a work session in here and actually start working on the assignment. Is that what you were thinking of doing, Sam? That hadn't even occurred to you. Samuel!
Yes.
All right. Well, then in that case, I will cut you loose to destroy yourselves in the way you find most fitting. Thank you very much for your attention. I will see you guys after Thanksgiving break. Right back here. See you then. Feel free to send me an